Welcome back to the channel. So we're going to start working on the cylinder today. Like I said last time, we've got the hole already in the center. It's still a little bit long. So the first thing we're going to do is turn these round sections on the end. And there's some steps here that you can follow to machine the cylinder. And the first step it shows is machining the round section on both ends. So to hold this, we're going to use an expanding arbor. This is a 1/2 inch arbor. As you tighten this screw on the end, which has a taper on it, it will expand this section out and grab tight to the cylinder. So we'll get this in the lathe, get this in the 3-jaw chuck, and then tighten this up on the end. And then I'll first just take a light facing cut to make sure we're good and square here. And then we'll start turning this down. It gets turned down to 15/16, looks like a 1/4 inch long. So we'll turn down the one end and then I'll get an overall measurement and then we'll turn it down. We'll face it down to the correct length and then get the other side turned down. So after that, if you were following the steps here, then we would machine out the center section on 2 sides, which we will do eventually. But after I get these ends turn down and get it to the correct overall length, then I'm going to do some layout on it. And my plan is to go ahead and drill these holes and these slots here that get milled into it for the ports before I mill out this section in the middle. I think it'll just be easier to hold it in the vise for doing these port machinings, and probably go ahead and machine these holes here to attach it. So once we get all that done, then we'll set it back up and machine out this section here to make the rest of the cylinder. But first thing let's do is get it set up and get these ends, get it to the overall length, and then get these ends turned around. Okay, so we got the ends turned down here to 15/16, 1/4 inch deep on both sides. We got all the holes drilled. I'm going to try to go over them. These 4 holes in the corner were drilled. It doesn't give you a depth on here, but I went 250 deep on these, and then that's tapped for 256. These 3 holes in the middle here are drilled with a number 57 drill, and there's 3 holes here, and they're an 1/8 inch deep. And then to make these slots here, since we're doing this on the drill press, it would be easy to mill these, but what I did was drill, these are 1/16 wide, and I drilled it with a 1/16 drill on the ends and in the center. And then in between both of the drill ends, I just plunged a 1/16 inch end mill, which on most drill presses, as long as you don't have excessive backlash in your drill press, you should be okay doing a plunge there. If you got something that's really tight, you might could do some light milling, but I just plunged it. So I plunged in between the 2 cuts, and then afterwards I did take a bit on a Dremel. I've got a really small bit, and I just sort of cleaned that up a little bit and made that a little bit better slot. So same thing on this side, you got 2 slots here, 1/16 wide. Then from this side, there's a 5/64 drilling that comes from the bottom, and then it comes all the way up to the end of these 3 holes here that was the number 57. Then down here on the end, we drilled and tapped this 540. So this is the exhaust in the middle. This is where the air or steam will get exhausted out through these 3 holes and then come down. Eventually we'll make a brass piece that'll screw into this that will be the exhaust, and then this hole on the bottom here is actually covered where you mount this down to the base. So your exhaust will come down through here and then out this hole here. Then on the bottom, we drilled and tapped these 2 holes here, which are 440. This is mounting it to the base. So once all that was done, then I set it up on an arbor in a 5C collet, and then it gives you a reference dimension here for this drilling at 16.5. So I cocked this over at 16.5 degrees. And then from this edge here, we marked the center when we was laying everything out, so I centered it up with this mark here, and then took the pointer and lined it up right on this edge here, and then move over 1/32, and then you're at an angle. You don't want to drill on an angle like that, so I took and plunged a 1/16 end mill and just made a flat here. Then I took the center drill and center drilled it, and then we drilled this out with a 1/16 drill bit, and then these come from each side into this slot that we made earlier. So this is the intake, so air or steam will enter this slot here and then come through this passage through here. So then we have the same thing on both sides, same drilling, flipped it over, drilled it again from this side. And then we have the same passage here. So then that will let air or steam into each side of the piston. Then on this, where I plunged that end mill, then I did machine it out to the inside and just made a slot both sides. So there's a little bit of an opening here because when the cylinder head will be flat on this and it'll cover this, but you still need a little bit of an opening there to get the air or steam to come to each side of the piston. So we have that opening there. So that concludes all of the drilling and tapping. So you can see I've got an X here and an X here on this side. So the next thing that we're going to do is continue on here with step 3, 4, 5, and then eventually 6. So on step 3, we mill a section. We mill this entire X here section off down this way, and we'll mill this entire X section off this way. So then this and this will get relieved. And then at a 45 degrees here, we're going to mill this point back some. And then eventually what we're looking to do is actually round this off from one side to the other. It doesn't have to be a perfect, I believe it gives it as a 5/16 radius here. That's what we're going after. We'll do both sides and we'll do it at a 45, and then we may turn it a little bit of an angle and turn a little bit of that off. But I'll probably finish that radius off with files, and then that actually gets covered. There's a brass lagging that goes over this cylinder. If you choose, it's optional, but if you choose to put that on there, it'll actually cover that up. So we'll get it as close to that 5/16 radius as we can, but it will get covered up with the brass. So we'll get this set back up in the lathe to do the milling, and then we'll mill all these sides off and then do a little bit of filing, and then that will complete the cylinder. Okay, so we got the cylinder machined now. So I set this up, machined out this section here, rotated it, machined out this section here. Then I actually set it up in a V block here behind it. So at a 45-degree angle, then I machined off this section here. Then I took some files and rounded this over here, and I used a 5/16 radius gauge to keep checking my progress. This is not a critical measurement here. We got it close to 5/16 and then kind of cleaned everything up with the Dremel, and that's what we ended up with. Turned out pretty good. So the next thing I'm going to do is there's optional lagging that goes over this cylinder here to cover it, this section up here. So I'm going to make this out of some brass. I've got some 16 thousandths thick brass sheet here. But to start with, I'm going to lay it out on a piece of paper just so I can get the dimensions and the bend lines. It gives you overall width dimensions here and dimensions of these flanges and a radius here, but I want to get the overall. So we'll get a paper pattern that fits this cylinder good. Then we'll transfer that over to the brass sheet and then cut it out. And then I want to go ahead and do this because there's bolts that holds it on. So we'll go ahead and get those drilled and tapped on the cylinder and get this lagging done. But we'll first do it in paper and then transfer it over to the brass. Okay, so I got the lagging done. So we made a paper template and then I put it onto the piece of brass, traced it out, cut these notches out, and then bent these flanges here. And then we drilled and tapped for some 256 screws. And the plans call for just one screw on both ends, but I decided to do 2 screws down here because there was enough distance here and enough material before it would hit this other hole to put 2 in. But on this side, these screw holes are a lot closer and there's more material here in the middle, so I did 1 in the middle here and then 2 on the ends there. But I think it turned out pretty good. So in order to make this easier to bend, I did anneal it. So if you just take your torch and heat it up when it first just turns red, so it's better if you actually turn the lights out so you can see what color that it is. As soon as it just turns red, then take the heat off and then let it cool, and then it's a lot easier to bend and it's not as springy. It'll stay bent easier around this. This is 16 thousandths brass, so be real careful with the torch because you can overheat it and melt it, burn a hole through it. But it turned out pretty good. So let's see what it's going to look like. So I think that's going to look pretty good. So we only have to drill 12 more holes in this thing before it's done. There's not going to be much left by the time we get all the holes in it. So there's 6 holes on each end that hold the head, the inner and outer cylinder heads on. So there'll be 6 holes that goes in this end, gets tapped, and 6 holes that goes in this end and gets tapped. But we're going to do that next time. We will make the cylinder heads, and then my plan is to actually super glue them on here and then drill them both at the same time. So you'll drill through with the tapping drill size and then drill through the cylinder head with the clearance drill size. And that way it ensures that they're completely lined up. So we'll start on the cylinder heads next time and get those drilled. Thanks for watching.